All right, so here we are continuing our lesson on graphing secant and cosecant with changes in the period and phase shifts. So here we're looking at the relationship between the cosine curve and its reciprocal function, which is secant. And we can see that where cosine is 0, that becomes asymptotes for secant. Where cosine has a maximum, that becomes a minimum for secant. Where cosine has a minimum, that becomes a maximum for a part of the secant curve. One of the things we need to understand is that the first cycle of secant is actually this piece right here, which actually starts at negative pi halves radians and then goes to 3 pi halves radians. We're looking at that piece for secant being our first cycle. Here we can see that just the table of values. One of the things I want to point out is at the pi fourths, these points here and here, those are the reciprocal values for root 2 over 2, and which is equal to the square root of 2. So this is the decimal approximation for the square root of 2 and negative square root of 2. And this being the first cycle, that is 2 pi radians. From negative pi halves to 1.5 pi, the period is 2 pi radians for secant. And then the domain excludes any values where there are asymptotes, and the range is the same as for the secant curve. All right, so let's look at graphing this problem here with y equals secant of 2x. So if we rewrite this with all the parameters in place, we're looking at 1 times the secant of 2x minus 0 in parentheses and then a plus 0. So the 1 is our a, the 2 is our 1 over b. The opposite of that minus 0 is, by definition, what we call c, and this 0 is our k. So the period is calculated the same way it is for sine and cosine, which are the reciprocals of our cosecant and secant curves. So we take our period of 2 pi radians, which is the period for the secant parent function, divided by our 1 over b parameter, which is 2. And that's going to give us a period of pi. So here we want to talk about the fact that, remember that the reciprocal of your 1 over b is your b parameter, and the reciprocal of 2 is 1/2. So what we actually have here is a horizontal compression by a factor of 1/2. So I'm going to make a little note. I've got a b value of 1/2, the reciprocal of 2. That's my factor of my compression. Phase shift. My phase shift is going to be 0 in this case. I'm taking the opposite of negative 0 to 0 and dividing by 2. So we're not focusing here on a phase shift or a horizontal translation. We're going to focus here on dealing with this change in the period. All right, so here we got to realize that anything that is not on the y-axis is going to be affected by this horizontal compression. And if we look back, that's going to include this asymptote that starts our cycle at negative pi halves radians. So at negative pi halves radians, cosine is 0. And that creates 1 over 0 for secant, which is undefined. This asymptote is 2 squares away from the y-axis. It's going to be compressed by this factor of 1/2 to half that distance. So that would put it at 1 square. So that puts it at negative pi fourths radians. Then what I've got is a period of pi. So pi units later is where the first cycle is going to end. And pi is 4 squares in this case. So 4 squares over, which would be at 3 pi fourths radians, is where the asymptote is that ends the cycle. Now you have to remember, halfway between these two, there will be a third asymptote where cosine is also 0. So 2 squares in the middle, we have a third asymptote here. All right, so now the pieces of the curve. So remember, cosine starts at 0, 1. That 0, 1 is not affected by a horizontal compression or a stretch. It is affected by a phase shift, which we don't have. It is affected by a vertical stretch or compression or reflection across the x-axis, which we don't have. and it is affected by a k parameter, which we also don't have. So what that tells us is that in this particular function, 0, 1 is going to remain 0, 1. But what would have been a maximum for the cosine becomes a minimum for this piece of the secant curve. All right, so if we know that that is a minimum heading up situation, then in the next section we have to have the maximum with the downwards curve. And that would be the same distance. So 0, 1, we'd have 0, negative 1. So we're looking at this same value, reversed. And then we can take this. So this is the first cycle of this particular secant curve. And now we can extend that. We're going to have a lot of asymptotes and a lot of little curves on this one. So every 2 squares I'm finding an asymptote all the way to the right. And then all the way to the left. And then we just got to keep track and make sure that our pieces of our curve alternate. So moving to the right, this one's going to be a relative minimum heading up, and then a maximum heading down, minimum heading up, maximum heading down, and so on. And then we reverse it towards the left. So if this is maximum, the next piece is a minimum over here, or a maximum piece heading down, the minimum heading up. So just reverses, minimum head up, maximum head down, and so on, to complete the graph as much as possible. And no partials in this one, but we saw a situation where we had a partial in the first example, so we can graph partials too, but unnecessary here. And that would create a decent enough picture of this particular secant curve. And that will end this lesson.